Greetings and welcome to the MLD Minute. Today is September 1st, and September is an exciting month for metachromatic leukodystrophy because it's both Leukodystrophy Awareness Month and Newborn Screening Awareness Month. Throughout this month, we'll be bringing you short videos with educational and awareness information that we hope that you will enjoy and that you will share with your friends and family. But today we're going to cheat a little bit. We're going to be a little longer than 60 seconds because we're going to show you a quick whiteboard that has been updated with current information for MLD, MLD research and therapies, and for newborn screening. We hope you enjoy this video and check back with us tomorrow.
Genetic diseases can be passed on in many ways. One common type of genetic inheritance is autosomal recessive, which means both men and women can get the disease, and both parents have to be carriers of the defective gene in order to pass it on to their child. Since each carrier parent has one good and one bad copy of the gene, each child has a 1 in 4 chance of being affected, with a 2 in 4 chance of each child being a carrier. One devastating autosomal recessive disease is MLD, which stands for metachromatic leukodystrophy. MLD was first discovered in 1933, and despite much progress in our understanding of the disease, there's still no cure. 1 in 100 people worldwide carry the gene mutation that causes MLD, meaning MLD occurs once in every 40,000 births. Let's delve into the biology behind MLD. It is caused by a mutation or a change in the DNA sequence on chromosome 22. There are over 200 different mutations that can cause MLD. The gene mutated is responsible for making an enzyme called aryl sulfatase A, abbreviated ARSA-A. This enzyme breaks down sulfatides, a normal byproduct of cell life. When ARSA-A is mutated, the sulfatides accumulate throughout the body, especially in the central and peripheral nervous systems, i.e. the brain, spinal cord, and nerves. The accumulation results in the protective sheath that surrounds the axons of neurons, which we call myelin, being destroyed. When neurons can no longer properly communicate with each other, there is a loss in motor and cognitive skills, resulting in a variety of symptoms that MLD patients experience, like inability to walk, loss of swallowing, respiratory problems, loss of speech and communication, reasoning, sometimes blindness, seizures, and unfortunately, eventually death. There are 3 different clinical forms of MLD. Late infantile MLD represents 50 to 60% of cases, with first symptoms between the ages of 12 and 24 months. It is often diagnosed after a child stops or fails to walk, loses muscle control, has difficulty swallowing and speaking, or shows behavioral changes. Progression can be very rapid, often measured in weeks and months. Juvenile MLD occurs in 20 to 30% of cases, with onset of symptoms between 30 months and the mid-teens. These children often show a decline in balance or walking, clumsiness, or a decline in school performance, changes in behavior or mental functioning. Although the progression of juvenile MLD is slower than late infantile MLD, it is still very severe. Lastly, adult MLD represents 15 to 20% of cases and occurs at any adult age, from late teens through the late 40s and beyond. Signs of adult MLD include personality changes, alcohol or drug abuse, poor money management, forgetfulness, and poor judgment, among others. These symptoms can develop slowly over 10 to 20 years before the disease advances severely. Because of these very broad symptoms, juvenile and adult MLD are often misdiagnosed and treated as ADHD, ADD, or psychiatric conditions. Interestingly, even though these different types of MLD have very different symptoms and times of onset, the underlying biology is the same. Degradation of the myelin covering around nerve occurs. The nerves can no longer communicate with each other, and symptoms of MLD result. Despite the same underlying biology, we don't know why someone would develop one clinical subtype of MLD versus another. We want to understand the relationship between the type of mutation, or genotype, to the symptom, or phenotype, to understand this more. What we do know is that MLD is an extremely severe disease for which there is currently no cure. Patients with MLD sometimes resort to bone marrow or stem cell transplant to replace the damaged marrow with healthy marrow that can produce the missing enzyme. Transplant for metabolic disease has improved over the years, but is still extremely risky. Because transplant cannot repair the damage already done to the brain and peripheral nerves, it is not effective for the late infantile form of MLD once symptoms have appeared, because of the rapid progression of this form of the disease. However, transplant has slightly better but far from perfect outcomes with juvenile and adults before severe brain damage has occurred. But there is hope. In addition to ongoing slow improvements in transplant, clinical trials and research is underway to study at least 4 other approaches to managing MLD's ravages. Enzyme replacement therapy and gene therapy are the furthest along in their trials. Meanwhile, the MLD Foundation is working on developing a newborn screen for MLD so we can identify every new baby before they show symptoms, so they can receive future therapies before extensive nerve damage is done. We are also gathering patient data in a registry so we can pursue data-driven MLD research. We are pushing to better understand the genotype-phenotype correlation and working with other rare disease organizations on cross-disease studies, because MLD does not live in a biological vacuum. This video has been produced by Eureka Science in collaboration with the MLD Foundation. To learn more about these and other projects the MLD Foundation is involved in, please visit the website and blog for current updates, projects, and information on research progress for new therapies.